A motorcycle is traveling on a straight road from 0 to 10 seconds. The position of the motorcycle is modeled by the function s of t is equal to t cubed plus 3t squared plus 15t. The motorcycle's acceleration can be modeled by the function a of t is equal to 6t plus 6, and its initial velocity is equal to 15 meters per second. At what time is the velocity of the motorcycle equal to 30 meters per second?
Our first method for solving this question is answering through an equation. Step 1 is to anti-differentiate to find v of t. Now, as calculus students, we know that velocity is the parent function of acceleration, or acceleration is the first derivative of velocity. Now, in our original problem, we are given acceleration. So, on the left, you can see the anti-differentiation process in order to find velocity for our final answer. Now, the anti-differentiation process leaves us with a constant known as c. However, we move to the right and use the initial condition, which is given to us in the original problem. V of 0 equals 15 meters per second. We plug these numbers in, 15 as v of t and 0 as t, in order to find that our constant is equal to 15, leaving us with a final velocity equation as v of t equals 3t squared plus 6t plus 15. Now we move on to step 2. Using our function v of t, which we have just found in step 1, we need to determine at what time the velocity is 30 meters per second. So we plug in 30 as v of t, and now we have to solve for t. Set the equation equal to 0 by subtracting 30 from both sides, and you are left with 0 equals t squared plus 2t minus 5, leading us to step 3. Now that our equation is set equal to 0, we can solve for t using various methods. However, we use the quadratic formula. So on the left, you can see that we ran through those motions, and we were left with the final answer of -1 plus or minus radical 6. However, because this is a real-life situation where we're dealing with a motorcycle speed, we reject the negative number because it's not realistic, leaving us with the answer on the right side, which is -1 plus radical 6. This is equal to about 1.449 seconds, which means that the velocity of the motorcycle will be 30 meters per second at about this time.
Another way to represent and solve this problem is through a graphical representation. So, as we explained in the first method, you can get the function for the velocity of the motorcycle. Therefore, to find out what time the velocity of the motorcycle is 30 meters per second, you simply graph the equation you found with the correct substituted values, with the function y equals 0. As you can see, there will be 2 intersection points. However, we must reject the -1 due to our domain, and that leaves us with our answer of 1.449 seconds. Therefore, at the time of 1.449 seconds, the velocity of the motorcycle was 30 meters per second.
Another method to solving the problem is a symbolic representation of the answer, and you could use your graphing calculator Math 8 to solve it once you determine what the time will be. And you could do this because of the relationship that exists between velocity and position, which is that position is the parent function to velocity.